Welcome to MarkScheme, Arithmetic Sequences. Everything you need, made visual. A famous story. A teacher, hoping for some quiet, tells the class to add up every whole number, from 1 to 100. Within seconds, one boy, Carl Friedrich Gauss, puts up his hand with the answer. No adding 100 numbers. He saw a pattern. By the end of this video, you'll see it too, and it'll hand you the entire sum formula. Before we start, here's exactly what this covers, straight from your syllabus. IB Analysis and Approaches, Standard Level 1.2. The nth term, the sum of n terms, sigma notation, and applications, including the link to straight line graphs. Tick all 4, and you've got the whole subtopic. Nothing missing. So what's an arithmetic sequence? Just a list of numbers where you add the same amount each time. 3, 7, 11, 15. Every jump is plus 4. That fixed jump has a name. The common difference, D. Here, D is 4. And here's a connection worth seeing early. If we plot each term against its position, the points land on a perfectly straight line. And the gradient of that line is D. An arithmetic sequence is just a linear function, sampled at the whole numbers. That's the link to linear your syllabus asks for. Let's build the formula instead of memorizing it. The first term is just U1. To reach the second term, we add 1D. The third term, U1 plus 2D. The fourth, U1 plus 3D. Watch the multiplier on D. See the pattern. To get to term number n, you take that many steps minus 1, because the very first term took no steps at all. So the nth term is U1 plus n minus 1 times D. That n minus 1, not n, is the single most common slip in the whole topic. We'll come back to it. Here's what Gauss saw. Take a short arithmetic series. 3, 7, 11, 15, 19. And draw each term as a bar. Adding them is the same as finding the total area of these blue bars. So far, nothing clever. Now the move. Take a second, identical copy of the series. Flip it back to front and lay it on top. The biggest bar now sits on the smallest. The second biggest on the second smallest. And so on. Watch every single column reach exactly the same height. Every column is U1 plus UN. The first term plus the last, which here is 22. We've built a perfect rectangle. N columns wide, U1 plus UN tall. Its area is n times that height. But that rectangle is 2 copies of our series. So the area is twice the sum. So twice the sum equals n times U1 plus UN. Divide by 2. And out drops the formula. No memorizing required. The sum of n terms is n over 2 times the first plus the last. For our 5 terms, 5 times 22 over 2, that's 55. You'll see this sum written in shorthand with the Greek capital sigma. Don't let it scare you. It's just an instruction to add. The number at the bottom says where to start. The one on top says where to stop. And the expression in the middle is the term you plug each value into. So our 5-term sum becomes sigma. K from 1 to 5 of 3 plus K minus 1 times 4. Let key run from 1 to 5. Write out the terms. And we're back to 3 plus 7, plus 11 plus 15 plus 19, 55. Exactly the same sum, just folded up neatly. Let's use it on a classic exam setup. My own numbers, but exactly the IB style. An arithmetic sequence has third term 8 and eighth term 23. Find the first term and the common difference. Then the sum of the first 10 terms. Turn each fact into an equation with the nth term formula. Third term, u1 plus 2, d equals 8. Eighth term, u1 plus 7, d equals 23. Subtract the first from the second. The u1's cancel, giving 5d equals 15, so d is 3. Put that back to get u1 equals 2. Now the sum. Use Sn equals n over 2 times 2 u1 plus n minus 1d with n equal to 10. That's 5 times 4 plus 27, which is 155. Notice I stated the formula, substituted, then concluded. That's exactly how the marks are awarded. Now the part other channels skip, the exam craft. First, your calculator. You can list a sequence and sum it directly. And to find when a running total first passes some value, just scroll the cumulative sum table. Much faster than solving a quadratic. Second, counting terms. It's last minus first over d plus 1. A sigma from k equals 3 to 10 is 8 terms, not 7. That plus 1 catches people out constantly. Third, how marks are earned. State the formula, show your substitution. Then give the answer. Method marks live in the working. And finally, paper 1 wants exact values. Paper 2 wants 3 significant figures. Before the recap, the 3 traps. 1. Writing n times d instead of n minus 1 times d in the nth term. The mistake we flagged earlier. 2. Miscounting terms in a sigma. From k equals 3 to 10 is 8 terms, not 7. 3. Using the wrong n in the sum. N is the number of terms, not the value of the last term. Dodge these 3 and the arithmetic series is free marks. And that's SL 1.2, fully covered. The nth term. Both sum formulas, sigma notation, and the pairing idea behind it all. Next in the course, geometric sequences, where we multiply instead of add. For more, that's markscheme.app. See you there.